Welcome to the third unit of the lecture Philosophy of Science. Last time I introduced to you the central goal of sciences, which is finding content-rich truths, true statements, hypotheses, law theories. 5 central epistemological assumptions which, so to speak, constitute a common core of all sciences. This was realism, fallibilism, objectivity and intersubjectivity, empirical basis, and logic in the broad sense. And 4 methodological features or building blocks, 4 methodological elements, so to speak, which you also find in all sciences. That was my claim. The search for general hypotheses, law theories, the search for empirical data. Third, the attempt to predict empirical observations by means of those general hypotheses. And fourth, the attempt to test one's general hypothesis about the domain of investigation by means of that, by means of the actual observed data, whatever they are. Now this unit we want to see whether and to which extent my conjectures about these common foundations of sciences, including natural sciences, social sciences, humanities, really fit to the actual sciences as they are taught in the university system. So now we take the notion of science as a descriptive notion and ask, do they really fit? And for this purpose, I start with the classification of scientific disciplines according to the domain of their objects. Now here you have this classification. This is the first step because we want to have an overview what kinds of sciences there are. And I would classify them as follows. You know, there are the sciences of nature, the natural sciences in the narrow sense. This notion will become important later on. So there's physics, chemistry, biology, geology, medicine in part, right? And these in brackets belong also partially to the sciences of nature, astronomy, etc. Okay. Then there's the sciences of technology, right? I mean, sometimes they are put into one group, but that's not really correct. If you go to the technical university, they will intensively protest against being subsumed under the natural sciences, right? So mechanical and electrical engineering and so on belong to those technical sciences. Of course there's an overlap, but I mean technical mathematics is applied mathematics, is taught in a quite different way than pure mathematics, just as an example. Okay. Then the third group is the science of human beings, mainly psychology. I put that in an extra category on very specific reasons here, you will see. In part also, parts of education, of medicine, of cognitive science belong to that field of psychological sciences. The first group are the social sciences, sociology, economics, political science, in part of these fields. The fifth group, I put them also in a separate category on reasons of philosophical, of science consideration, history, right? In particular, human history. History as a discipline of the history of humanity. There are differences between historical disciplines and others. Then the sixth group are what I call the sciences of cultural artifacts, in the very general sense, artifacts as man-made entities as opposed to natural entities which have been produced by non-human evolution. Sorry. So, let's go back. So here you find the legal sciences, linguistics, literary science, science of fine arts, etc. Then the seventh group is a special group. This is the keyword is mathematics. 7 is mathematics, sciences of formal structures, mathematics including the formal methodologies like statistics, etc. And finally, the group 8 is philosophy in general. I call that the sciences of the general foundations of human ideas, right? Philosophy. And the ninth group are the sciences of God, right? Theology and religious studies. Now, note that science in the sense that they are taught on the academic university systems. I mean, whether they're really sciences, theology, is another question I will speak about soon. So this is my proposed classification here. Next observation. If you look, you see there are certain categories which are used in the university system and which not really clearly defined, in part have more political, partly have political status more than substantial status. For instance, you might ask, given this classification, what belongs to the natural sciences, right? Only this group? Or this and this group, probably, these two. These are the classical natural sciences. Maybe also three. Psychology. I mean, this was a turn that took place sometimes I would say in the 1970s or 80s, that psychology moved from the humanities to the natural sciences. And there was a big controversy, because there's psychoanalysis, psychotherapy in psychology, that these parts of psychology wanted to stay in the humanities, while those parts of psychology who did a lot of experimental work wanted to go to the natural sciences. And in the end, the natural science fraction won. Why? Because mainly on political reasons, the natural sciences are more powerful in our Western society, because there's more money involved in the application of natural sciences, much more, significantly more economical profit involved in the application of natural sciences than of humanities, I would say. And therefore, usually the natural sciences have more money, and also they are more costly because of their experiments. And on that reason, psychologists, the majority of them wanted to go to natural science, and so today they are natural sciences. But of course, as you will see soon, that methodology of psychology is really still different from that in physics or chemistry, although it's of course again different from humanities. But that's on that reason I put it in a separate group. There's the word humanities, the category humanities, in German Geisteswissenschaften, sciences of the mind, right? This is some old-fashioned term. 5 categories, 5, 6. Well, first of all, here, natural sciences. Well, okay, humanities. 5 and 6 belong to them, and of course 8. But you might ask, why not 7? What is the status? Where do mathematics belong to, right? Why is mathematics so clearly part of the natural sciences in our university system? Actually, mathematics is a science of formal structures. Like linguistics is a science of natural languages, mathematics is a science of formal languages. So it's in this respect, it's a humanity, right? It's a discipline of the mind, a Geisteswissenschaft. But since mathematics is applied in natural sciences a lot, maybe probably more than in the humanities or the social sciences, although this has changed in the last decades. Now mathematics is also applied in the social sciences today, in the economics, in the psychology anyhow, but that's a natural science today. But I mean, the fact that mathematics is part of the natural sciences, not of the humanities, is just also some kind of historical political fact, I would say, but it's not so really substantiated by matters of fact. By the way, in analytic philosophy, the discipline to which philosophy of science belongs, mathematics plays also an important role. Okay, so humanities, right? And maybe some people would say psychology really does belong to humanities, though it's not clear. Then there's a category of human and social sciences. This category was formed in the 70s as an opposition against the imperialism of natural sciences, right? Natural sciences, in particular when evolution theory was generalized, became somehow imperialistic and tended to take over all fields of investigation, and then the humanities formed an opposition. An opposition which, by the way, goes back to the 19th century, to Wilhelm Dilthey and so on. And though the humanities, in Germany, Geisteswissenschaften was old-fashioned, so humanities, human and social sciences was coined. Later on, cultural sciences was coined as such an opposition to natural sciences. And in the English-speaking countries, it's cultural studies, right? But again, these divisions are really not more political and not clear. You see here all this question mark. What goes to what is not substantially decided. It's not decided by matters of fact here. By the way, you have a lot of interdisciplinary disciplines too, even today. Right? Cognitive science, where does it belong? Actually, it belongs to here, it belongs to social science, belongs to cultural science, and to formal sciences, right? So, yeah. Good. Now, there's also, of course, this notion factual sciences as opposed to structural sciences. I mean, this is the opposition of all disciplines, right, from 1 to 6, maybe also even 8, as opposed to 7. 7 are the formal sciences. There's of course a clear difference between them. My question is now, how can we demarcate sciences from non-sciences? I explained in the first unit that this problem should not be taken as a kind of ideological problem, but it should be taken as a task of philosophy of science to suggest such a demarcation to society as a means of demarcating what should be taught publicly, what is, so to speak, common knowledge, which in our educational system should be passed to everyone, and which is more or less a matter of subjective belief. This kind of demarcation is an important demarcation, which has to be somehow decided or somehow negotiated. So, how do we demarcate the sciences from the non-sciences, given these common foundations of the science and given this classification? Well, we have to take care that the formal sciences have an exceptional status. This is very important. Why? Because, of course, you may ask, do we find all these building blocks of the sciences which I taught in all of these categories? And it seems quite unproblematically, yes, we find logic in the broad sense in all of these fields. I mean, not actually every science applies logic in the field of humanities, but you can do it. I mean, and I say you should do it, right? And you should, and in all of these fields from 1 to 6 you find empirical data. I will speak about that in a minute. So it seems that in all of these, even in the humanities, you have empirical data, right? But of course, obviously not in the formal sciences, right? I mean, the theory of natural numbers is not abstracted from observing factual objects and counting them, but it's a mathematical science. So here we have an exception. And what is the exception? The exception is the following. Mathematical science is about formal objects. So the special status of mathematical sciences results from the fact that mathematics deals with abstract objects and not concrete or physical objects. So concrete objects are in space and time. Abstract objects are conceptually constructed objects like numbers. So there is not the number 3 lying out there, right? I mean, there are, for instance, 3 objects here, right? There are 3 pencils here, right? And there are 3 chairs, they're here. And here are 3 fingers, but there is not the number 3. The number 3 is an abstraction of all these sets of concrete objects which have 3 elements. And the laws of mathematics are not laws about the real world. They are not synthetic laws, so to speak, but they are purely logical laws, laws which can prove by means of logics as in the following way. If you assume certain mathematical axioms, like the axioms of the natural numbers or the axioms of Euclidean geometry, then a variety of mathematical theorems follow. So for instance, take geometry. This is a good example. I write it on the table. Geometry. It makes no sense to say that the axioms of Euclidean geometry are per se true or false. I mean, what should that mean? Yeah? They are mathematical axioms, right? Of course, you may ask, do the axioms of geometry apply to the real space of our universe? Do they correctly describe the laws of this space? Well, then you speak about geometry as part of physics. Then you speak about physical or physics geometry. But then, of course, geometry is no longer mathematically certain, right? And then the distances in Euclidean geometry are not mathematical objects like certain sets of real numbers, which are linearly arranged. But then the distances are physical distances which you may measure by light or in some physical way, right? Physical distance in real space, which are not mathematical distances. So Einstein, you know very well, it's very well known that Einstein showed that actually our real universe is much better described by non-Euclidean geometry, curved geometry, right? Because of relativity theory. This was discovered in the beginning of the 20th century. So this also shows that mathematical models, it's a very different question to ask whether they are true or false in reality than whether to ask whether they are mathematically correct. Einstein once said, as far as geometry says something about our real world, it is not certain. And as long as geometry is certain, like all mathematical theorems are certain as mathematical theorems, and as long as geometry is considered as mathematically certain, it does not refer to the real world, right? But it refers to an abstract conceptual system described by certain axioms. In other words, you can say that mathematics just is the most certain discipline of all disciplines just because it abstracts from reality. So what the mathematicians do is a certain auxiliary job for the empirical sciences, for the sciences which have an empirical domain. The mathematicians, it's a kind of division of labor. The mathematicians investigate certain axiom systems which describe quite complicated structures like geometry and see what follows from that logically. And of course these mathematical structures must have some similarity to things which we find in reality. They can be more or less fruitful, more or less well applicable, often applicable, right? But they are not per se true or false, right? And the mathematician shows you, well, if the mathematician proves that if the axioms are true, then these and these and these theorems are true. The mathematician says to the empirical sciences, if you grant me the truth of the axioms, I grant you the truth of the theorems. And for complicated structures, it turned out in the development of advanced sciences that this is a job of its own. It's just see what follows from what. And therefore, this group of mathematical sciences has specialized as an auxiliary science for the empirical sciences. So that is how I would characterize the sciences of formal structures and why they are there and why they have this exceptional status. So this brings me now to my final suggestion, how we could demarcate the notion of science in the broad sense of the word. So sciences, I would say, comprise all the empirical sciences which satisfy the common goal, finding condensable truth, the 5 epistemological assumptions, the 4 methodological building blocks, plus the associated formal and methodological auxiliary sciences in group 7. So that is my suggestion of demarcation here. Good. Well, any questions so far before I go on? Yes, please.
Yes, so why do you include the history of biology in the sciences of nature, but not the history of humans in the science?
Yeah, that's a good question. I was not sure. It could also be done here in that way. That is clear. It's a matter of taste. But I mean, in some sense, the history of organisms is so much. It's closer to the sciences of nature than the sciences of history. And also, if I would really group all historical disciplines in one field, I would have to include here, of course, cosmology. So we would have a group consisting of cosmology, evolution, theological evolution theory, history, in the ordinary sense. Well, yeah. But you're right. Good question. There is one specific thing in historical disciplines. While the non-historical disciplines, when they seek for contentful hypotheses, they always search for general hypotheses, for generalizations. In historical disciplines, these generalizations, of course, are used in research, taken from other fields, like generalizations, like the measurements of carbon, how many million years it's old, how many million years it's old based on the carbon-14 methods, which is taken from chemistry and physics. But the goal of historical disciplines is to find interesting hypothetical singular hypotheses about historical events, like why did the dinosaurs get extinct, right? It's also a hypothesis, of course, but in that case it's not a general, it's a particular hypothesis about a particular historical event which is far in the past, which can only be discovered by way of a lot of theoretical inferences. But that is a specific thing of historical disciplines that they're interested in, also in particular events, like the Big Bang theory. What was in the beginning of the universe? Right? That's a historical question, right? The velocity of speed, the curvature of the space. These are typical questions of physics, theoretical physics. But what was going on in the first milliseconds of the Big Bang? It's also a historical question. Okay. Any other questions at this point? Maybe also if not, then I proceed. So we have this demarcation, and now, well, let's see it a little bit critically. Let's ask: do we find really in all these disciplines empirical data? I mean, this is quickly said, right? But let's see, well, in the science of nature and technology, I think it's completely unproblematic. In psychology, you make experiments with humans. In sociology, it's also clear. There you have on economical sciences. There you have this discipline called microsociology, where you make experiments with little groups of humans, small groups of, say, 20 people, and can investigate how they interrelate or interactions between them and whatever. Or you make interviews, like then the data are the results of interviews, of interview tests or whatever. In the history and in the cultural sciences, in the science of cultural artifacts, the humanities, here the data are usually not given by an experiment, but just as a record. Like in history, you have just source materials, historical records of all kinds. You might have also archaeological findings, like right, as in archaeology, if you go to the history of a more distant history of human mankind, and in evolution history of biological organisms, you have fossil findings, fossil records, and so on. In the science of linguistics, you have just the factual languages as an empirical basis. It's very obvious, and you investigate the factual natural sciences, how the grammar works, and so on. In the literature sciences, the empirical bases are just pieces of literature here. The diverse poems, novels of certain periods of literature. Maybe you come up with hypotheses about certain literary styles in certain epochs and so on. All this work fits quite well with the model which I presented you, where I have this empirical basis, you generate general hypotheses, you have these test procedures, you try to explain your findings, you try to predict new ones, you test your hypothesis. So I think in all these fields science can be done in that way. Of course, some parts of these scientific disciplines are more theory loaded, are not so much engaged with collecting empirical data, but in all of these fields you find the empiricists, the empirical people who are doing empirical work and collecting empirical data today. So of course the method of philosophy is quite similar to the method of philosophy of science, which I told you in the first unit. It's a method of rational reconstruction, which has both an empirical corrective and a normative corrective. That is how I would describe the method of philosophy in general. The method of mathematics, I just said, this is just a formal group of formal sciences. So it seems that the model of science which I gave you is applicable. It seems so. Of course, there have been counter-arguments. For instance, in the so-called philosophy of humanities, which was founded in the end of the 19th century by philosophers like Wilhelm Dilthey or Wilhelm Windelband, yeah? There was a school of so-called methodological dualism. They argued, they would have argued against my model here as follows. They argued at that time, and some people even argue in that way even today, like for instance certain school of qualitative research to take up much of what these people started to say. They set up a certain opposition between natural sciences and humanities. They argued that natural science and humanities are the methods of the two fields are really significantly different. So you will see it in the course of my lecture. Do not deny that there are important differences. But I don't think that what they said is right. I think it's basically wrong. So they argued, this is where the slogan, in the natural sciences we explain, and we explain by means of general laws like Newtonian physics. In the humanities we understand. We understand what a certain person did in history. We understand, say for instance, what Hitler did, or what Ludwig XIV did, or whoever, big figure, Stalin in history did. We understand his deeds, but there are no general law hypotheses involved here, right? So it's basically different. They are good. There are no general law hypotheses, no general laws in history, therefore you cannot apply the model of natural sciences to the humanities or to historical sciences. But in my view, the mistake of this school is that they conceive the notion of law in a much too narrow sense. With law they mean like something mechanical law of Newtonian physics, which is a strict and exceptionalist law, which has no exceptions. And of course, you don't find laws of this sort in history. I mean, there are no strict laws. Of course, humans are to some sense freedom and unpredictable. I mean, not in a strict sense, right? There are no laws which rule how a dictator like Stalin or whatever proceeds, or in a fascist regime would develop. Or there are no strict laws saying when a liberal society turns into, say, dictatorial society, right? With fascistic tendencies. There are no strict laws like Newtonian mechanics. But there are statistical trend laws. right? And in modern understanding of philosophy of science, the notion of law is taken in this much general sense of statistical law, statistical trend law, normality laws, right? Laws telling you qualitative statistical trends in most cases, right? Or in psychology, most laws with which empirical psychologists come up today are just statistical correlations, right? So eating too much or eating a lot of meat increases the danger of heart infarcts or increases the blood pressure, right? But not specifying here a certain quantitative relationship. And similar, it's a statistical trend law that in history that if societies develop in a way such their economy goes down, the economical welfare of being goes down, then the political development shows a tendency to become more conservative. And fascistic regimes arise more often in such situations than in situations of economical prosperity. These are examples of these trends. And if you take the notion of law and hypothesis, general hypothesis, in this general sense, all these claims of the methodological dualism school vanish. And you have what I teach here, you have these common foundations, which allows for diversities between different fields, but still there is a common foundation. So, let's put that away then, because so far, still there's a problem. And this brings me to the next part. There are limitations of science, and I mean in two places. The first limitation is, I'd start with the second limitation. The second limitation is, in my sense, in my understanding, quite clear. Where assumptions of faith or religious creed enter the discipline, there we don't have any longer what I call a science. Why not? Because, you know, it belongs already to the assumption, to the epistemological assumption number 2 was fallibilism. So, and the assumption number 4 was empirical justification. So in science we only believe something to that extent we can empirically confirm it. And to that extent we cannot confirm it in an intersubjective way. We don't believe it. We doubt it. And doubt in science is a critical attitude, is to a certain extent always wanted. Doubt in science is certainly not a sin. It's not morally dubious. However, in theology, it's very different. There you have a certain dogma, which is also called a religious creed, which is just a dogma of faith. You have to believe it. So that's out of critique. That the core of a religion is out of critique. And that dogma has to be believed. Because if you doubt it, you are not a good believer. It's a sin. Catholic Christianity teaches that doubting is morally bad, right? And other religions, related religions, do the same. Though it's clear that this doesn't belong to science. Right? And this is what you understand by theology. So, I mean, of course you can empirically study what is the content of religion and what actually certain different religions teach as their faith or their religious creed. Then you pursue religious studies as an empirical discipline, and religious studies as an empirical discipline of course belongs to what I understand by the notion science, right? But a theology, insofar it is bounded by authority, its beliefs are bounded to a religious dogma, does not belong to this group of science, right? And there is of course a political debate to which extent theological departments should have a place in the university systems. Theological departments which are bounded to a certain religious creed or a religious church And I don't speak about this political debate now. I mean, even if they are taught at some universities, it's not, that is a different question whether this should be the case. What is important is to understand that if something is taught somewhere, it's not a science, right? It's a religion, but it's not a science. So this is clear. So therefore, Group 9 doesn't really belong to this notion of sciences, right? As I demarcated that. But this is, I would say, quite uncontroversial. What is really more controversial at this point? The point is that wherever evaluative statements, values, enter the discipline, it also clashes with the internal limitations of sciences, like political values or so, because value statements cannot be justified in a scientific manner. That is the thesis or the question, right? So this is the second limitation. This brings me now to the topic, the famous topic of value freedom of science, question mark, or value neutrality of science. So let us start with the cultural sciences, with the first example from the cultural sciences. And this brings me now to the next page. For instance, there is a subdiscipline of the sciences of jurisprudence, the science of legal judgment. It's a science which is teaching that what also a judge does, namely a judge finds out whether a certain concrete action, deed, right, is a criminal offense or not, falls under a certain paragraph of the law, of the criminal law or not, right? And the question is can this science of legal judgment really be done in an objective way, or is it dependent on subjective value statements, right? Well, this is discussed in a lot of also contemporary writings on the philosophy of law, of legal sciences, like Eike von Savigny and Hilgendorf and Coulon more recently. And they ask to which extent this discipline is really value-free. And the argument is it's not really value-free. I mean, it was the position of the so-called positivists of law, like Kelsen, or legal positivists, that this can be done in a value-free way. But the point is this: the law, the actual law, doesn't really fix all details, right? There is always a certain interpretation involved. For instance, the question, is a billboard advertising underwear still in accord with common decency, or is it already a legal offense, right? A billboard showing like nice girls almost naked, right? Advertising for underwear, right? Is it tolerable legally? Because it's, of course, being in common descent is a paragraph in the criminal law, right? I mean, that's clear. But what is common decency? Of course, this notion is not defined in the law. This notion is taken from the cultural value background, and this cultural value background has significantly changed, right? The billboards which you advertised today would never have been tolerated, although the law hasn't changed, would never have been tolerated 2 generations before in our countries. And no wonder that people coming from countries where they have a cultural background which is more similar to our background 2 generations ago, like Islamic countries where religion is dominating, no wonder that these are shocked when they see this, right? Because they think that is an offense, right? Against the law, because they interpret the law very differently, because the implicit value judgment which are needed in interpreting laws, which they use, are different than ours. So that here, for instance, value judgment enter the discipline, and in that sense, go beyond the border of objective science is the thesis of Savigny, and it's also pointed out by Hilgendorf and Cullen. Right? So the question is, how should we proceed then? And the answer is, which I want to suggest, and which basically goes back to a very famous person, Max Weber, is, of course, we should not be silent about laws, about values, but we should make them explicit and distinguish them from the factual hypotheses which can be scientifically confirmed. We should separate them. So if a scientist of legal judgment interprets this, then it should be very explicit that the notion of common decency is interpreted depending on the cultural background. And this cultural background, what is the right limit here, what is decent or what is not, is not scientifically decidable, but is a question of democratic consensus. It's a question of negotiating in a culture. So that, for instance, should here be the right position. So, any questions up to this point? Yeah.
In regard to this case, shouldn't you also admit that maybe a judge is not a scientist, but a political figure also in a way?
A judge is not a scientist, but there is a science of legal judgments. Yeah. So there are scientists in the jurisprudent scientists, there's the legal judgment science. In Germany it's called Rechtsdogmatik, and they answer these questions in their publications, right? What follows, right, from the law in respect to, for instance, these and these actual practices, right? And for them, this question is absolutely essential, right? So should certain advertising there try to answer a question of that sort? Or other questions is, for instance, giving shelter to a criminal in one's own home, is this already amount to complicity, right? If a friend of mine has done a criminal act, like stealing something or murdering, it's a friend or a relative of mine, and I'd let him sleep in the night in my home, did something criminal then? Am I guilty because of that? Other questions? Yeah.
Perhaps regarding your demarcation slides before, when you were presenting it as an on-off property, being scientific or being non-scientific, but what about thinking it in comparative terms? So say something like the natural sciences are more scientific than, for example, the typical humanities, but then you also know that the humanities are more scientific than, for example, theology, and you know where that drops out or not. So do you think you really have to demarcate it with an on-off property, or you think it also makes sense to make these comparative claims? And
well, I like this on-off. It's very important whether you really makes these separations between value judgment and empirical supported judgment and creeds. Three groups: creeds, empirical supported judgment, value judgments. I wouldn't really like to have a gradation here, because I mean a gradation would just be a mixture, and of course if you're looking at, the answer is this: at the normative level, the on-off property is important. At the descriptive level, of course, at the actual sciences you find mixtures. Not lots of scientists, when they apply their findings to practice, makes these mistakes, about which I will speak now, or confuse values with hypotheses, or don't separate them clearly, or even don't want to separate them on principled reasons. And in this, general hypothesis, in this general sense, then you can get such a graduated scale too, right? But of course there's no, that's what I would say. Of course, let's go on and now come to Max Weber and so to speak the core of the topic and the question value neutrality in science. So this brings me to Max Weber. Max Weber was the founder of the social sciences, and maybe the founder of sociology. And he set up the postulate of value freedom, and that was very important for social sciences because of the following. Max Weber was involved in the controversy with a guy called Gustav Schmoller. This was 1912 or something, before the First World War. So Gustav Schmoller, this is a so-called Weber-Schmoller controversy. Very interesting. So I write it here on the table. Weber-Schmoller on the blackboard. Controversy. Also called the first value judgment debate. Because there was the second value judgment debate in the 60s, and a third value judgment debate took place 20 years ago in the USA, in the English-speaking countries. But this was the first and most important one. So Schmoller, and he was not alone, suggested the following distinction between the natural sciences and the humanities. The natural sciences should tell us what are the true facts, and the social sciences should tell us what are the true values. So, given you have a socialist, I mean, this was a time where there were a lot of political movements, so the socialists would then say, well, you should teach at the teaching desks in the university, at the podium, so to speak. They were called podium values. You should teach the values of socialist ideology. But of course there are conservative or nationalistic parties too, and they would then say, well, no, you should teach the nationalistic values, and so on. And the communists would want to teach at the universities the values of communism, right? Of communist ideologies. Well, and Weber said, well, no, come on, objectivity cannot be reached in that way. We cannot found sociology as a science in that way. We must really separate between scientific judgment and values. Also sociology, even if it's true that sociology is concerned with humans having values, so with factual value systems of humans, even if this is the case, and because this was an argument of the opposite camp, of the Schmoller camp, right? They said, well, social sciences have to do with humans, with human values, so they of course deal with values, right? But Weber said, no, in spite of that fact, we are value free too. And why? Because well, the major reason which all defenders of value neutrality would still have as their major reason, the major argument, right, for the value neutrality of science is clear. Values, right, are not properties inherent to objects themselves, but are based on subjective interpretations by us humans. So this is just a naturalistic worldview, a part of that. Right? So therefore, because of that subjective nature, they cannot be objective facts. Right? Right? So they are in conflict, of course, with the methodological and epistemological assumptions of science. They are not objective. So they don't belong to what can be objectively justified. Ultimately, the decision for or against certain value question is a question of personal freedom. Now, in this last sentence, you see the emancipatory function of the value neutrality postulate. It has an emancipatory function. Why? Because, right, it prevents that certain people, that experts stand up and decide what is the question of your personal freedom for you, right? So they say, well, but it's good. It's good to have monogamy. Polygamy is bad, objectively bad. Therefore, you must not do this. That's an objective value, right? Or whatever. Or, well, what else? Whatever it may be. I do not deny by saying this that there are certain values, right, which are really intersubjective in the sense that almost all people in almost all culture hold them. And to this extent, these kind of values have some kind of intersubjective legitimacy, right? Although it still works differently than the empirical sciences, because intersubjectivity here would be the reason, but in the empirical science it's just a criterion, right? Because although these values are not properties inherent to objectives themselves. But if values are very intersubjective, of course we can have some kind of quasi-objectivity here. I don't deny that. But the really delicate and practically relevant value questions are always questions about which value is more important than which else value. Is safety more important than personal freedom? Right? So the protection of data from spying, like the whole debate now, all these debates which we had now, what is more important? Protecting our computer data from being spied by the CIA, or a little less risk concerning terroristic attacks, right? What is more important, and so on, right? Or what is more important, the ecological integrity of our atmosphere, or economic welfare in terms of a high employment rate with high CO2, carbon dioxide emissions, polluting our atmosphere, right? What is more important, and so on. So these are typical questions of value decisions which I don't think can be taken. This load of value decision is basically, that's at least the viewpoint, the scientific viewpoint, is a matter of democratic decision and democratic negotiation, but it's not something which a quasi-expert can take over and say, well, that's scientifically now confirmed or verified that a certain value system is the right one. That is not going on. Okay, so, but on the other hand, if you take value freedom in an absolute sense, it would of course also be not really productive or constructive, because of course sciences have to do, sciences should and are expected to apply their results to society. They should have practical implication. They have to do something with values. That is for clear. So the value questions should not be, so to speak, left over to irrationality. The question, what does it mean, these scientific findings for our value decision, should not be something which is completely irrational and which is out of the responsibility of the scientist. But this fact was also seen by Max Weber, who argued and pointed out that this does not mean that scientists have no word to say about values. There are three aspects in which scientists and science can set up and state objective facts about value questions. First of all, Weber said, the scientist qua scientist can study the factual presence of value systems and norm systems in different societies, like and this is what this is most important for social scientists, because and for cultural scientists, because they study, of course, factual value systems of different societies. But to discover or to recognize a certain value being defended by a certain group of people does not mean that we pass judgment, right, and take over that value. If we study polygamy, right, for instance in Islamic countries or whatever, that doesn't mean we are proponents of polygamy, nor does it mean we are opponents. We're just, it's a purely descriptive questions, right? To observe that some people have certain values doesn't mean anything for my own value system. Even if I study the values of a person like Hitler, for instance, and his racistic ideology, and I want to understand the sheer unbelievable deeds of this dictator and racist, and is in a certain sense completely mad person. But I can, and this is the person of a social scientist and a cultural scientist here. I have to try to understand why he did it and what was his value systems, and that doesn't mean at all that I share these values. And the same goes for understanding, say, primitive tribes and their value systems, which is equally maybe equally distant from our value system, and still we want to be able, and still we are able to discover this value system empirically, like a cannibalistic tribe on the Polynesian Islands, right? And I mean that these cannibalistic tribes had still very delicate and very developed value systems, right? Cannibalism for them did mean entirely different than for us, right? So studying the empirical presence of values and norms does not mean at all that you pass judgment about values, right? So the first thing. The second thing, so this is important for social science. The second activity, scientific activity, or second scientific enterprise concerning values, scientific occupation with values, concerns the logical relationships between value and norm sentences. They bear certain logical relationships. For instance, a certain norm can imply another norm, and this is in particular important for finding out whether a system of values like the actual law in Germany is consistent or not, right? So actually, in our system, in our states, modern states, which are constitutional states, which have a constitution, a legal constitution, where you have a variety, many different laws, it's very easy that some laws come in conflict with others, and actually these conflicts occur actually all the time, and it's an important business of legal positivists, of the logicians of law. There's a special discipline, a discipline of its own, which only deals with the logic of norms, right? Geontic logic and the logic of norms. So these disciplines have the task to discover logical relationships between norms and to find out inconsistencies. This is the second thing Weber said in which science become important for values. But the third thing is even more important, and it's important for all applications, for all practical applications of scientific discoveries. So this third application, kind of dealing with values in science, concerns all empirical disciplines, but especially the practical disciplines, and it contains the following. Scientists can infer derived norms from given fundamental norms and descriptive knowledge, and they do this by means of the so-called means-end inferences. And this means-end inference is the following inference. The means-end inference, right? Given a certain descriptive knowledge, M is in a given circumstance C a necessary means for the realization of an AND E, or maybe even an optimal means. This is a second version, right? Given we have empirically found out that if you want to realize E, you have to apply M. The only way to do it, or the best way to realize E, is by means M. And given the fundamental norm, E and E is to be realized, right? And E is to be realized. That fundamental norm is not scientifically justifiable, right? That is taken over from the society, or from the politician, or from the user of the scientific discipline, from the user. If this is given, then the scientist can say, then means N should also be realized, right? So the scientist here derives a certain norm about the optimal means from a given fundamental end and a certain descriptive knowledge. That is the way in which all scientists can become and do and should become practically important. Right. And actually, there is a variety of derived norms which follow just from a few fundamental norms. Right. For instance, if the fundamental norm is you should not any longer apply nuclear power and nuclear plant as an energy producer in Germany, then the technological scientists say, well, then the best thing is to do this and that, like build a lot of windmills, maybe open the coal mines again, which have been closed. You could also, of course, import oil or gas from Russia or whatever, but then they have this and so on, right? But of course, the scientist cannot decide by himself what is right, what risk we should take in our energy production system, right? What is a risk which we should really take? Should we forbid nuclear plants in general, or should we allow them to a certain extent? What risk level is here acceptable, right? Weighing costs, risk level, maybe one major nuclear accident per 100 years or per 50 years, like in Fukushima now, where then 100 kilometers of area is just devastated because of radiation. Or should we forbid them generally as a method of energy production and take the risk of carbon dioxide pollution in the atmosphere by coal mines and coal plants, or what should we do here? So these decisions are political decisions which the scientists, of course, has to take from the society. The scientists can say, but these are the fundamental norms and the fundamental value constraints here, then these are the optimal means. This is the means and inference. Okay. Well, what is important in the means and inference is that the practical scientist makes clear that this fundamental norm is not scientifically, first, that the scientist explicates the fundamental norm on which his recommendation is based, right? That makes it explicit, yeah. So it's not silent about it. That is the first important thing. And second, that the scientist makes clear that this norm is taken over or just assumed as a value, as a fundamental value, but is not itself a scientific fact. You speak also of, in this connection, you call the derived norm a hypothetical norm, right? That is an old philosophical terminus here. As opposed to a categorical norm. Categorical norm or value. Norm or value. So the scientist, in other words, can derive hypothetical norms, mean recommendations, or you say also instrumental norms, but not categorical norms. To give you another example, which I take from my cooperation with educational scientists, educational scientists found out that if cognitive success is a major goal of teaching in school class, then 80% of class time should be teacher guided, right? This is an empirical finding. Then the educational scientists should say to the teachers, if cognitive success is your major goal, 80% should be teacher guided of class time and 20% should be group activity. If the scientist just tells the teacher, you should have 80% teacher guided and 20% group activity because that's the best, then he suppresses his value premise, right? That cognitive success is a major goal. Because in educational scientists, it has also been found out that if social intelligence, social learning is an equal goal besides cognitive success, In's rule, and which is also important, right? Then group activity should be at least 40% of class time, right? So, I mean, this is the second thing which the teacher should tell, which the science, the educational scientist should tell the teachers, right? 40% group activity, social intelligence is on equal importance as cognitive success. And if the scientist tells the teachers you should do 80% teacher-guided class time, but the teachers have different fundamental values than the expert, they are badly recommended by the expert. So you see again the emancipatory function of the value neutrality requirement, which basically is nothing than a separation requirement here. Namely, an expert can only be useful for the user if the values which the expert presupposes are the same as the values of the user, right? So, for instance, if going to medicine or to physician, my physician told me I should have my meals, right, and also my son should have his meals, not in the evening, but at noon or in the afternoon. So, because that makes it just the best thing for us. But the fact is, the only family time which we have is in the evening. And if we would do our meal sometime in the afternoon or afternoon, then the joint family time would completely be eliminated, and there would be no social activity more and no joint family time going on. So this side effect was not realized by the doctor. So actually his recommendation, I didn't follow his recommendation then, although from a physiological viewpoint he was right, but it was not the right thing, because the family time is more important for me than this physiological thing, I mean, which I can compensate by other means like physical training and so on. So this is the really important message here. Fundamental norms, if should always be made explicit, and if they are used in deriving practical means recommendations from scientific findings, these fundamental norms are not themselves scientifically justified, but they are taken over from the users or from other instances, and therefore the scientist has to make them explicit and has to separate them from the descriptive findings, from the scientific findings. Okay, good. So, before I come now to the final version of the value neutrality thesis, a little pause. Are there any questions up to here? Yeah.
Are you also going to talk about risk communication, or because I mean this
yes.
is not mentioned by you here, but it doesn't help if the scientists say with 0.5% risk there will be an accident with a nuclear plant. So you should just come up with your values, and then you just calculate. But you need also some kind of instruction how people should use this.
Yeah, I will speak about this in the third part of this lecture, because it already assumes and presupposes certain knowledge about probabilities. But basically, the consequence then is the same. The scientist, for instance, if the scientist evaluates whether a certain nuclear plant should be used or not, the scientist should never say, well, it's practically certain that the nuclear plant is safe, but the scientist should come up with a certain risk information, where the risk is such and such. Like you find it in the prescriptions of drugs, right? That is important, and the pharmaceutics experts have really learned a lot here in the description of drugs, because of all these legal processes which they had. In every description of drug you have risk information, lots and lots. The risk is such and such. So in 10% of cases, if you take this pain compensator, then or pain relief pill, then there's a risk of 5%, say, of stomach pain. There's a risk of 1% of dizziness, right? But it's left to the user whether they take that risk or not. And the similar thing I would recommend for scientists which have to do with risk assessment. I mean, they can recommend something, but they should inform the risk about the risk or the risk of error of their hypothesis, and the last decision has the user. That's the point here. Yeah. Further questions? Okay, so then we come now to the final version of the requirement of value neutrality in sciences. And to come to that, we have to make two further differentiations. The first is, several philosophers have pointed to the fact that, of course, there can be no value freedom in the absolute sense in the sciences, because sciences themselves are defined by certain goals, namely the internal supreme goal of the sciences, to find rich and contentful truth. So, since sciences are defined there, of course, there's a central value which defines them. And these are called the internal values of science. To the internal values of the sciences belongs the supreme goal of the sciences and all values which follow from this supreme goal by means and inferences. So, for instance, you should collect the methodological building blocks. You should collect data is also a scientifically internal value, because that's a necessary means for finding contentful rich truth. Or you should find out what are the logical consequences of a hypothesis. It's all the value internal. But for instance, that is important not to confuse with. You should, when you make animal experiments, you should not kill apes or monkeys. That is relevant for science too, but that is external. Yeah, obviously. I mean, how important is it to avoid pain, to avoid producing pain for animals in relation to having certain insights by which we maybe can produce drugs which help humans? So I will come back to that soon. But first, you see this decision. So we have internal values. This distinction, I mean, we have the internal values and we have the science external values, which are all values except the internal ones, like political values, religious values, how you should be dressed, how nature should be like, and so on. And the value neutrality thesis has to be restricted to the external values, more specifically to the fundamental external values. So we can derive norms. There is also a fundamental value in science to which we are obliged, the scientific internal value of finding contentful truth. But science cannot justify or warrant fundamental external values. That is the claim. But even that is too strong. Even this is a little bit too much. Why? Think about this animal problem, this animal experiment case which I just spoke about. Of course it is relevant in some sense for science whether and to which degree we can use animals in our experiments to find out what is the optimal drug for humans. Right? But that is an external question. So we must distinguish between science as a social process and science as a cognitive question of justification, as a cognitive process, so to speak, or a logical relation. Science as a social process is unavoidably also involved in external values, and the question to which degree we should be allowed to make experiments with animals or not is such a question. So I'm saying this question should not be decided by biologists alone, but that's a question, ultimately a political question, which it has to be decided politically by a kind of democratic consensus. So for this purpose we must make a further differentiation, namely the distinction between three contexts, and that is a very commonly agreed distinction in the sociology of science, which is in the philosophy of science, which is a little bit broader than the theory of science. So there are three contexts, as you call them, or parts of the social process of science. the context of discovery, the context of justification, and the context of application. In the context of discovery, first of all, it is determined what is the goal of investigation, which things should be investigated, say in pharmacy or say in medicine, to which questions most money is flowing, right? Or say in physics, is it for military purpose or for what, which research is most important, right? So this is the context of discovery. For instance, in the new rulings of our university, there's a passus which saying that the research en gros at this university, the Heinrich Heine University, should be devoted to peaceful affairs, not to war. Right? That is something which is such a weak guiding norm belonging to the context of discovery. Right? Okay, in the context of discovery also, for instance, then as a next step, it is determined which parameters are measured, right? Which parameters are studied. And this is a question of relevance. For instance, in medicine, it may be decided to study diseases and illnesses of humans. We concentrate on organic parameters, physiological parameters. It's also a decision in the context of discovery. In the context of this justification, then, these more four methodological building blocks works, right? You collect data, given your relevant settings, what parameters are measured, the design of the whole research project and the kind of experiments, you collect the data, you generate hypotheses, you try to explain with the hypothesis data, you predict new ones, but in this way you test them, you confirm them. Ultimately you come up with a paper, research paper, saying, well, these hypotheses can be rejected or weakened, this hypothesis is best. This is the context of justification, ultimately coming up with certain degree of confirmations of certain hypotheses. And then the third context is, of course, the context of application, where you apply your scientific findings. And of course, again, here, it's clear that external values play a role. So in the context of discovery, of course, massively external values play a role, because the external question, which questions are interesting, which are not, right? And it's clear that in the context of application, massively external values play a role, right? Because it's an external question for what purposes science is applied. Is it applied, for instance, are psychological findings applied to improving family relations? Or are they applied for increasing working efficiency, right? And to improving school teaching? Where is the money going? Okay. So the question of value neutrality then reduces to the context of justification. This is the major insight here. In the context of justification, here, the question to which degree a certain hypothesis is confirmed by the given empirical data, this is independent from any fundamental external value judgment. This is a basic claim to which now the value neutrality requirement reduces it. And this is, I think, really the basic insight which already goes back, which already Weber had, which goes back to Max Weber, and which is now much more precisely formulated than it was in these earlier times. So this is a formulation of the value neutrality requirement then. Here is it. A specific realm of scientific activity, namely their context of justification, should be free from fundamental science external value assumptions. This is a normative recommendation, by the way. I do not claim that it's followed by all scientists in all disciplines. Generally speaking, in our science, there is always the danger of scientists being abused for political purposes, supporting certain political decisions in a way where you don't want to relativize the underlying external value. Saying, for instance, that windmills are fine in in a scientific report for the Green Party, right, you don't want to say much about problematic aspects of windmills, right, in terms of other values. You find a certain bias in pharmaceutical disciplines, in a lot of research papers where you find that there's a certain positive relation between positive results about certain drugs and the firm which paid for the research. So this is a normative recommendation which is so to speak a permanent demand for scientists to follow this rule, to separate external value assumptions from scientific findings, and in this way to prevent ideological abuse of science, right? In any way, in any direction, whatever it is. Good. Any questions so far? If not, then I come to a final point. The final point is this. The selection of the investigated objects, right, and parameters in the context of discovery is not epistemologically neutral, but places limits on the possible results of scientific investigation in the context of justification, right? Therefore, the selection in the context of discovery must be accessible to subsequent correction by results in the context of discovery, and in the context of justification, I mean here, even when this goes against the external goals of the research project. So let me give you an example. An example is medicine. In classical medicine, until, say, to the 1970s and 1980s, and even to some extent today, there was a certain maxim ruling the context of discovery of medical research. Organic diseases have organic causes, right? Therefore, for instance, diseases, stomach diseases, heart diseases, diseases like dizziness, were studied by searching for organic causes of them, right? Metabolism deficiencies or whatever, blood pressure deficiencies, whatever, right? So, later on, the so-called psychosomatics come up. The psychosomatics was fostered especially by psychologists who said that certain organic diseases have psychological causes. So psychotherapists now have something to say in the domain of medicine, right? So like certain stomach diseases, digestion diseases are purely psychological, or certain kind of dizziness, or even asthmatic diseases have psychological reasons, right? Are caused by certain neurotic symptoms or other psychological problems. Classical medicines, physicians and medicine scientists didn't want that. So they first of all, they defended their authority. But that is our domain. That has nothing to do here in our domain. The psychologists should leave our discipline, right? But then you see, this is dogmatic, of course. This maxim here can only be preliminary, right? So it should be falsifiable and correctable. You can, whether the psychosomatic thesis that there are correlations here is true or not, can we find out only by investigating psychological facts in the domain of medical diseases, right? Only by deliberating, by including other parameters in the context of discovery, you can find that out. Therefore, it was, of course, absolutely important that there were then psychosomatic studies in the 70s, in the 80s, and there were a lot of findings which supported that. And nowadays, it is quite accepted in medicine that there are psychosomatic effects. So this is an example where the parameter selection in the context of discovery in medicine in the 60s and 70s was corrected by findings, scientific findings later on. Good. Question to this? Last fact? Anything else? Okay, then let me conclude. We have seen that the goal, the 5 epistemological assumptions and the 4 methodological building blocks are applicable to more or less all scientific fields with 2 limitations. First, assumptions of religious creed have no place in science. Second, there is a certain value neutrality requirement, which is an important maxim, and to the extent this value requirement is violated, it's no longer a scientific finding, but it's a value judgment. And the value requirement says that what you see here, that in the context of justification, the question of the degree of justification of scientific findings is independent from fundamental science external value assumptions. And that is the end of the today's lecture. Thank you.